Good afternoon, New York. We are at 12:01 p.m. on this beautiful, almost beautiful Wednesday in May. Thank you for joining us for our 12th installment of our Turner panel series, Step Towards a Carbon-Free Future, focusing on building electrification. My name is Lisa Hickerson. I'm the Business Development Manager for Turner Construction. And today I have the pleasure of not only being your host, but also your moderator for this great event. And I have to admit, I've already learned so much from our panelists today in our initial discussions, so I'm really excited to be part of today's conversation. I do want to give a special thank you to the Cosentini team, Molly, Whitney, and Doug. I know you're out there. Thank you for helping us develop this topic and this discussion for today, and arranging for our panelists to be part of the conversation. So just some rules of the road before we dig in, not much different if you've joined us before. There is a Q&A feature at the bottom of the screen. Please feel free to type in any questions throughout the course of the panel discussion, and we will try and field as many as possible at the end. And if we don't get to it, we promise we will follow up. If you are experiencing any technical difficulties during the program, you could email nyevents@tcco.com. And hopefully we'll be able to resolve everything and get you back up and running so you don't miss anything part of this exciting discussion. Well, let's dig right in, right? We're all looking for ways to increase energy efficiency, save money, use renewable energy, reduce reliance on fossil fuels. And our guests here today are on the forefront of executing this vision, which is wonderful. Just a fun fact, 1/3 of all GHG, greenhouse gas emissions in New York State, come from heating, ventilation, and air conditioning systems. Clean heating and cooling solutions help our businesses reduce GHG emissions and meet our sustainability goals. So imagine the possibility of a world where we don't have to burn fossil fuels in our buildings, and as a result, we have cleaner air, and I think more importantly, safer and more affordable housing, healthier, more livable communities for future generations. So building electrification is a step towards a carbon-free future, and it's going to help us leave our city in better condition than when we found it for future generations. So with that being said, let me introduce the people that are initiating this change. So we have Jared Delaval, CEO and founder of Alloy Development, Greg Macarone, Vice President, Cosentini Associates, Andrew Wall, MEP Project Manager, L&M Development Partners, and last but not least, Greg Hale, Senior Advisor for Energy Efficiency Markets for NYSERDA. So there has been a lot of attention focused on carbon reduction, greening the grid, Local Law 97, you name it, a lot of attention. So I think before we dive in, the best place to start is to bring everyone up to speed on some updates on the regulatory environment. So Greg Hale, hoping you could help start us off and give us an update.
Sure can, Lisa, and thanks for hosting this series. It's really important, and for having me here today. I'll try to go really quickly through this. I could spend the whole time talking about this, but we got lots of other good stuff to cover. I want to talk about it both from the state and the city level. So the state, in 2019, the legislature passed and Governor Cuomo signed the Climate Leadership and Community Protection Act, or CLCPA. It's very ambitious. We think the most ambitious of any major economy in the world, with the targets it's setting, which are to reach carbon neutrality by mid-century, with some specific milestones along the way, which are at least an 85% reduction in greenhouse gas emissions by 2050, with anything remaining coming from offsets. And along the way, importantly, cleaning the electric grid. So it's a requirement that we get to 70% renewable energy on our grid by 2030. That's just 9 years from now, and 100% emission-free grid by 2040. And that's so important because that makes building electrification a tool to decarbonize. You know, if you have a dirty grid, then electrifying your buildings isn't going to help anything, but we are on the path to a clean grid. We can talk about that a little bit later. We do think we are on track for those goals. So that's exciting. Anything that we do, though, if we're going to make these targets, requires a carbon neutral building stock across the entire state. At the same time, the city has passed the Climate Mobilization Act, roughly the same time frame. Local Law 97 is the centerpiece of that, which sets actual carbon emission limits on all buildings over 25,000 square feet in New York City. And those limits, the first period for compliance starts in 2024. It's right around the corner. And they ratchet down 2030 and in 5-year periods after that steeply. So it's set to capture the 25% worst performing buildings in the first compliance period, but by the 2030 compliance period, it's set to impact 3/4 of the buildings that are out there. Now, there is a carve out for certain regulated affordable housing where there's a prescriptive path as opposed to the emissions caps. But that's still requiring significant action from those buildings. And then the other point is there are major penalties for non-compliance at $268 per ton. That translates into, it could be millions of dollars for very large buildings that are really bad performers. Going back to the state, both of these acts are currently in the middle of the sausage making. There are all sorts of stakeholders, experts on advisory panels and working groups figuring out, okay, what are the specific requirements and regulations going to look like? How are we going to get there? And from the state perspective, it's governed by what's called the Climate Action Council, 22-member body. They are in charge of developing a scoping plan, which is the plan to reach these ambitious targets. They just had their working group that was focused on buildings Monday present their final recommendations to the Climate Action Council. So these are real, and they are serious recommendations. For example, on the regulatory side, recommending that our new construction requires zero carbon buildings by 2025 for single family homes and by 2030 for multifamily and commercial buildings. Also a benchmarking, so that's new construction, also a statewide benchmarking leading to a building performance standard statewide by 2030, which would look something like Local Law 97. And don't freak out. We are working to align these so New York City buildings don't have to comply with 2 separate sets of recommendations. The other really powerful tool here is a recommended ban on fossil fuel appliance replacement after 2030. So if you're after that point, if your fossil-fired heating equipment goes down, you can no longer replace it with like kind. You will have to electrify. So the regulatory push is coming here, and that's what's so exciting about the projects that our other panelists are going to talk about, because they're showing how this is practical. A mandate doesn't work unless it's practical, unless it's workable. And the point is, we can do this today. So let's find out what our folks are doing.
Awesome. So Jared, perfect segue. 100 Flatbush is set to become the first all-electric residential tower. So you had a crystal ball. Hopefully it has the lottery numbers as well. With all-electric power replacing components that are normally run by natural gas. Would you mind telling us a little bit about the building and what made you decide to go all electric at this point?
Well, first of all, thank God I did it, because what Greg said just scared the bejesus out of me. And I didn't even know about all the scary stuff that was going on, but we honestly, we started to see major shifts in both construction technology, changes in acceptance on the residential marketing side that we thought would yield a better opportunity. And at the end, there was a spat over the extension of the pipeline, the National Grid's pipeline, and whether or not we'd be able to get gas service at all. And we started to ask Cosentini, who are our partners and engineers on this, to do studies on, well, what would happen if we didn't actually get gas to the building, and how would we solve it? And as we started to consider it, as I mentioned before, construction technology has certainly changed, where hot water production and cooking, right, were the 2 primary typical barriers to entry, which are really no longer barriers to entry. And from our perspective, this was our first generational asset. We've historically done condominium buildings, and 100 Flatbush is part of a block-wide assemblage that is going to be a rental project for us. And we're thinking to ourselves, why would we build into technological obsolescence, right? Why would we not think about this? The block includes the first passive house schools for the School Construction Authority as well. And as we think through these barriers to entry, we started to say, look, we have a real obligation to lead here. We may be a little bit ahead of the curve, but this is clearly, coming at us. And in the end, as we started to think about the penalty system that Greg's talking about, imagine what the influence is on the terminal value of an asset when major financial institutions, banking institutions, or otherwise are starting to take ESG investing with a serious lens. And how is the real estate industry going to catch up to that? And at the same time, how will that influence the terminal value, right? Is a pension fund who has ESG requirements going to invest in a building that has technological obsolescence and outdated infrastructure? The answer is no, right? We're heading to a system where it's like, why are we investing in copper wires when we can do everything wirelessly, right? Like, why invest in those things? And fundamentally, as we get into the panel, I think people will realize that it wasn't really clairvoyant. It was something that was missing from the market, and we're prepared to take a risk. For us, it's the beginning of a portfolio versus an end, and we're not trying to manage how we think about our other assets. We're trying to future-proof them, as it were, begin to think about ownership over the long term, and really, honestly, be accountable to the industry.
Good. So Andrew, L&M took a little bit of a different approach, but following along electrification for the Marcus Garvey project in Brooklyn through the use of geothermal wells. Can you give us a little bit more insight on that development and what made the team go down that route?
Sure. So Marcus Garvey is made up of 6 affordable housing buildings in Brownsville, Brooklyn. 3 of them are in construction, nearing completion. The other 3 are in pre-development. And when we first started designing the first 3 buildings, we were faced with the potential loss of gas during the time when National Grid was limiting or even denying the gas connections. So, after several energy models, local law 97 studies, cost analysis, we decided to leverage a strategy we use at our Beach Green project in the Rockaways and go with an all-electric geothermal system. However, since we were designing without gas at all, we opted to rely on the geothermal wells for not just heating and cooling, but for domestic hot water as well. So this was a challenge, though, because number one, at the time, there were not many manufacturers that we knew of that sold water source heat pumps dedicated to potable water. Number two, the ground conditions were not ideal for the optimal conductivity. In fact, the BTU per foot per hour was 1.3, which is well below average. And number 3, the building profiles were all the same, so there was no diversification. In order to adapt to those conditions, we had to set up additional measures such as extra storage capacity, backup electrical heaters in the tanks, just to make up for any loss of efficiency or higher than normal loads. But during the study, we found that geothermal allows for the lowest tenant operational costs, and since the ground handles a portion of the temperature lift rather than an air source compressor. Unfortunately, though, the drawback is the upfront cost of the well fields. Depending on the location and the conditions, those costs can range from $15,000 to $20,000 per well, and that's at 2 to 3 tons of capacity if drilling lengths are kept to 500 feet. However, though, we found there are some significant incentive programs through both NYSERDA and the Joint Utilities programs to help offset some of those costs. For example, Marcus Garvey, we were able to go after the custom cold climate heat pump program through Con Ed, which provided $150 per aggregate MMBTU savings compared to a nationally designed building. So overall, the strategy at Marcus Garvey was to use the well field, because it can provide an all-electric solution, and according to our energy models, the data coming in from previous projects does have the lowest impact on the utility grids, and it produces a sustainable solution.
Got it. So Greg, being on the design side, and Andrew alluded to it, right? Is there limitations in the materials available, to support a full building electrification, or are we behind the times? What's your thoughts on that?
So the United States in general we've always liked it bigger and better, but we've been very slow to move to new styles of design, new styles of products. So is the current crop of products out there 100% good fit? No. We have limitations specifically on the Northeast is the heating side. I think the air conditioning is 95% electric already. And it's really what Jared got to is domestic hot water and being able to produce domestic hot water and heating, being able to heat in a 0-degree atmosphere. I think, the VRF manufacturers have done a great lift in the last 10 to 15 years of really pushing their products and being able to do air source cooling and heating. But there's definitely room to grow here. And we're seeing more manufacturers come into the market as of, the last 6 months to start trying to fill those holes, because NYSERDA has been pushing incentive programs that allow manufacturers for L&M and alloy to use different products that we normally wouldn't look at. So.
Sure. Well, I can imagine, especially in a residential, everybody wants to be able to take a hot shower, huh?
Yes.
Are there any alternate design options out there to help supplement some of these lack of materials or products?
We can get into a building to work all electrically. Whether it be through electric boilers or air source heat pumps or geothermal, there's a lot of different pieces to plug together. However, operating cost becomes the next sort of big jump, right? And how do we reduce that operating cost or the amount of capacity we have to bring into the building, right? So historically, putting in a bigger boiler was never a big deal, right? And gas was cheap and no one really cared if you put in a bigger boiler and it only ran 50% of the time. However, if you have to put in, 3 more Con Ed vaults in front of your property, you're going to care. So I think, the industry on a whole needs to get tighter with how they design systems. We need to understand the buildings more effectively and how they operate so that we put in the right size equipment so that, putting in an electric boiler means a smaller capacity that runs more at the 100% mark. And I think there's a balance there, right? Because, we're looking to make sure that the equipment that we put in is right sized for the space and for, the future.
Yeah, I mean, if I could add just for a second,
Absolutely.
The basis for design for these buildings, and it's the fundamental basis for all of our projects, has to be a high performance building envelope, right? The single largest influencer of the demand that we're putting on these systems for heating and cooling is the building envelope performance. So once you start getting into air tightness and thermal performance, for these buildings, we're not talking about electric resistance heating here, right? Which is how people think of an all electric building, right? For the most part, the building systems are identical, but if we can reduce the demand and the call for energy use, and then use the building in different ways to offset when we're picking up that energy at off-peak times or otherwise, then there's a lot of work that can be done. You can't just take
You can't just rely on the MVP systems to make the lift, because then NYSERDA and Con Ed are going to run out of power, right? Because we're just burning too much energy.
And even though our building is today dirtier in some ways than gas because the grid is not caught up with us, we are still 20% more efficient than a traditional building because of the performance of the building envelope, right? And to Greg's point, as the grids merge and we start heading toward a sustainable, 70% of the grid having sustainable energy sources, our building will continue to get cleaner over time, right? And it'll become 200% cleaner than a traditional building by the time 2024 rolls around, or 2030 rolls around, such that we're building into a future where our performance gets better over time. So a small investment today means a big difference later.
Yeah, and I'd say that we are pretty close to parity in terms of emissions today, even with the nature of our grid, which is only going to get better from here. We took a bit of a step back when we retired Indian Point. That was all planned, however, and we still are on track to get to the 70%. So as we go forward, your building will just get cleaner and cleaner. And the point about envelopes is so important. From NYSERDA's perspective, we need to think about societal system wide. So most people are focused on their own buildings, and that's understandable, but we need to reduce the load in all of these buildings as we're doing the transition to minimize the additional lift that we have to make on the grid side.
So then, Jared, I mean, you hit that point about the facade, and obviously, I'm sure there's a lot of developers on the phone here. When you do your initial assessment to determine whether or not you're going to go electric, what were some of those initial assumptions that you made? Was there a baseline standard that you assumed your building had to achieve in order to be able to execute a fully, electrified building?
Well, we started, with a basic design where we were considering passive house for our building, but the building geometry being triangular such as it is was, the amount of, wall surface to floor area was just a ratio that was, never going to be achieved relative to getting to a passive house standard. But we were pursuing zone green from a building envelope performance, which has certain zoning, opportunities to it and zoning benefits where we're getting to deduct floor area for thickness of building envelope, which allows and affords us the ability to get to this performance standard. But we also had, meaningful EIS considerations because we went through ULURP where we had, air and noise considerations as well, given our location. So the basis of design for our building envelope was already at a high standard. And I think what we were just candidly coupling that with is, everybody in my office is an architect, right? We're an architecture-led development company. And more than that, I'm a father with teenage kids. And those teenage kids today, my 14 and 16-year-old, they do not buy food that's wrapped in plastic. They will not buy firsthand clothes, right? They will go out of their way and they will spend more on items that meet their value set. And when I realized that these renters who are 16 now are my renters in only 10 years from now, the idea that people will be shopping with their value set, right, for real estate in a way that they haven't traditionally been able to, became an incredibly compelling story because the demographics for renters is mid-20s to young 30s, working in the technology, advertising and media industries, who are making an extraordinary amount of money, but choosing on where to spend their purchasing power. And so I needed to be both responsible to my family and coming home and saying, this is how I'm making a difference in the lens of the things that you care about. But those things align perfectly with the business case for why make an investment, at this point, why try to re-steer a ship that, has historically not gone this way. Again, I don't have an operations and maintenance team because this is the beginning of a portfolio for me of work. And so it's a new way to set a standard. Unlike SCA, which, is the city's largest contractor, which had, real challenges in considering the operation and maintenance and how that might be different for a passive house building up against a traditional building. But, first and foremost, a parent, right? And feeling like this is our obligation and those decisions were made there. And our basis of design was already in line with, the way that we see the industry going and our obligations as architects and, as developers to say, we need to drag the industry with us. And, it seems, again, clairvoyant, but it now seems also very obvious.
And that's another place where NYSERDA wants to be a partner here, is in this demand. It's great to have some of this inherent already in the next generation, but we are really going to be leaning in at one of the major tools that we want to employ is consumer awareness. So how do we go out and get to renters, residential renters and commercial office tenants and let them understand the benefits of being in spaces that are like this? And it's not just lower energy bills. There's health, productivity, all sorts of co-benefits, as well as helping to address the climate situation.
Well, COVID is
So
no
we will
doubt
be
been
leaning
a
in.
stimulant, right? I mean, it's been a significant stimulant relative to shifts in our desire for sustainable futures and also high air quality environments, right? And those combination of things is kind of bulletproof.
Yeah, every tenant is more aware of what filtration is and, products of combustion and, how it interacts with our life.
So, Greg, staying on the facade topic, right, and how Jared mentioned that's a big factor. What are the keys to success to make sure that you can get energy savings? And I'm going to integrate a question we actually got from the audience. How can you integrate and use the facade envelope to supplement the energy demand, like circulation of water, PV, solar, hot water?
So, when you do a really high performance envelope, there's an initial first cost, right? And, that needs to be managed. But, you look at, the passive house standard or the FIAS standard that really pushes you to be facade driven. And we look and we see buildings that historically, you would have a 1-ton air conditioner in a living room, and we're using a 1-ton unit to condition an entire 3-bedroom apartment. So not only, your energy profile goes down tremendously because you're capturing and keeping all the energy that you produce inside that space and making sure it doesn't escape. Or when it does escape, you try to draw all that energy out of that. So, if you do a high performance envelope, it's a trickle down sort of operation. The HVAC system gets smaller. There's less components for you to maintain or replace as your, the life cycle cost of the building. Now, and that's purely on the HVAC side. When you get to domestic hot water, that really is that doesn't really change, on the envelope side. That's really changing the way people, conserve water, how long they take showers, right? And how we use the water. So low flow fixtures and making sure people get instantaneous hot water rather than having to run your faucet and wait 30 seconds, right? Because we're trying to balance, water reuse, reduce, and the energy it takes to sort of produce that domestic hot water. So there's, we've been studying several systems such as like sewer heat recovery, because all that hot water is going down the drain, and we now have the ability to capture that heat. And, there's installations out in Colorado and Vancouver where they're able to support 90% of their heating loads through the sewer energy that's leaving the building. So we're in several studies with several buildings in the tri-state area that are realistically looking at this system to offset their heating loads.
Yeah, our clean heating and cooling team is very focused on heat recovery from the sewers. Really worthwhile avenue to pursue.
Yeah, that's really interesting. Jumping back to the geothermal, Andrew, I know with the Vital Brooklyn project development, I think you were taking a different approach to how you're studying and tying in the district systems into a single loop. Just curious what was driving that decision, how the evaluation is going, if there's any advantages or disadvantages that you could share.
Sure. Yeah. So a little background on the project. It's actually 2 large complexes we're studying, Vital Brooklyn and Arvern East. They're new development complexes that are currently in design. Combined, they're about 4 million square foot of affordable housing, commercial, retail, and community facility components. And we're studying district geothermal systems in addition to other sustainable technologies like passive house, as Greg mentioned, wastewater regeneration, solar PV, and some others. And the only way we're going to use gas is if it's specific to like a commercial kitchen or something that requires it. What drove that decision was just, with the hope of reducing operational costs and taking advantage of the large footprint that we were given. There's a lot of ground area, and you have a lot of ground area with, with different types of buildings, you can achieve loop balance and good diversification. So what we learned during the study, and is that by tying the loops together and capturing other forms of heat generation, you can actually cut down the upfront cost of the loop field by reducing the overall required ground area anywhere between 30 and 50% compared to a traditional geothermal system. And what we learned is that the reason because of that is because of the balanced cooling and heating dominant buildings. If you have residential that's heating or cooling, and you have a commercial that could be the opposite, it actually balances the loads, and you could have, it's easier to achieve because of the different peak times during the day. The disadvantages, though, of course, are the high upfront costs, and the payback period is longer than a typical investment program. But if you factor in the incentive programs and offset with solar or wastewater regeneration, it could help ease that burden.
Got it. I'm going to throw a little curveball question from the audience, but it's related to the geothermal, Andrew or Greg, if you want to answer. They had mentioned about building their house 15 years ago and having to have a certain number of cores and holes and having to reach the water table. And the question was, is geothermal possible on most projects in New York in the big city environment, or is it more feasible in surrounding areas?
I'll take a shot at that first.
Sure.
Okay.
So what we learned is that there's a certain height of building that kind of pushes geothermal away. If it goes above 10 stories, or if it's a small footprint, then you obviously can't get enough holes within the 20-foot, 18-foot on center to really get some good heat rejection into the loop, unless you're drilling down,
Thousands of feet
down, which has additional other complications. So we found that there's like a cutoff about 10 stories where it starts to make sense. We were studying for a different project. We're working with Cosentini that we're looking to do geothermal, but we were only getting about 200 tons worth of capacity, which was almost about a quarter of the total load. So we had to go push away from that. So yeah, and basically what we've learned is that you get about 2 to 3 tons of capacity per well, depending on the soil conditions, but it's around that.
Right, and that's realistically a closed loop system. I think the question was like trying to hit a well.
Yeah.
That would be an open loop solution. So open loop solutions we tend to shy away from. Like St. Patrick's Cathedral has an open well geothermal system. Those historically have been very expensive to install, especially in the Manhattan area. And as Andrew said, as your footprint gets smaller and your building gets taller, you lose the benefit. So, majority of the geothermal systems that we're looking at are closed loop systems. They have higher life expectancy, less maintenance, and you're really relying on just the tubing in the ground to dissipate the heat, rather than trying to pump water in and out of the systems. So basically, if you have enough property, geothermal tends to be the right approach. But Manhattan is going to be a little bit difficult.
So in that case, let's focus on the grid.
Yes.
Yep, Greg Hale, right? The concept obviously seems logical, but as it's been brought up, and it's been brought up in a lot of questions here, is it feasible? Is this feasible with the state of the grid, and the number of buildings here in New York to really push this all building electrification?
Well, the answer is yes, asterisk. We understand the number of buildings. It's not feasible if we just electrified all the buildings today with the existing grid infrastructure. We would have problems, but that's not what we're doing. We understand the additional loads that we will be putting on the grid. Interesting that New York City just came out with a study that they co-designed with Con Ed and National Grid on the impact of electrification in New York City. And their conclusion was it is feasible. There are different elements to this. There is creating enough, getting to our statewide goal for renewable energy and clean 0%, 100% emissions free by 2040. We're on track for that. even with the retirement of Indian Point. The New York ISO has known about the upcoming retirement for years. You know, it was very hotly contested. The safety concerns versus the clean energy benefits. You know, we all know where that wound up. ISO is all in on using efficiency as much as possible these days to satisfy grid demands. But this is why envelope work, energy efficiency work, and load flexibility are going to be so important as we make this transition. And we need to be able to shift our energy demands around to reduce the impacts on peak demand, because peak is, of course, what you're really building the system to. So the use of batteries, the use of thermal storage to be able to manage your load is going to be super important going forward. So we've got the right, we do believe that, so we're at 27% renewable energy today, statewide, mostly hydropower. But we have contracted or awarded renewable projects that will take us up to 48% just with what we have on the books already. And we think that will be built out by, 26, 27. And then we are confident we'll get to the other 20% through further procurements on the way, at the tail end of this decade. Then you got to get the power to New York City. People get that too, right? And transmission has to be part of the equation. We're actually scheduled to make a decision on the first large scale transmission line, the new of the next generation of new transmission lines coming into the city within the next day or two at NYSERDA. So this is happening now. They're awarding the projects and we're unsticking these transmission projects. The Champlain Hudson Express is a good example that is one that's under consideration right now. Once you get the power down here, and then there's offshore wind, going to be a massive development of offshore wind, big economic opportunity, port infrastructure, lots going on there that NYSERDA is leading. When all that comes together, then it's the distribution system. So there are all sorts of elements here. It's not just getting the power here, it's then distributing it out to all of the buildings without overloading any of these individual distribution lines. So yes, it's going to require a lot of investment, but we can make it.
Awesome. Greg, there's about 400 questions on the grid, so there's going to be a lot of follow-up, just an FYI.
Yeah, good thing I'm a buildings guy and not a grid.
You'll have to point us in the right direction.
The big thing here is like the microgrid environment, right? Mm-hmm. Large developments that can produce power at their facilities, and changing the legislation, being more open, specifically on like the Con Ed side, being able to get that power back out of microgrid environments and to feed other entities, right? And incentivize power generation, whether it be solar, wind, or any other sort of battery technology, so that we can keep that power. If power is produced at a building, and we could sell it to another building rather than having to store it or waste it.
Okay. Shifting back to the building itself, Greg, I'm going to stay on you. How going electric, how does it impact the rentable square footage? Assuming that there's some type of reduction in floor area, for the equipment, or what can you explain about that?
If you're stating I'm going to build a code compliant building and then swap to electric, there's no real, the space savings, there's no benefit, there's no negative impact to it. However, if you start to implement zone green, FIAS, passive house programs, you're picking up rentable square footage, because we're reducing, the amount of componentry that we need inside the building. Like I said before, like we're cutting cooling loads in half, right? In several of the occupancies. So, we have half the amount of equipment on the job. You're picking up another 2 to 4 square feet in every apartment.
Wow. So the residential demand is a lot different than, let's say, for commercial tenants. You know, how easy or difficult, because we've been speaking mostly residential today, how easy or difficult is it to achieve full building electrification in other building types, maybe such as commercial? Greg, I'd like to direct that to you.
It really comes down to the heating, right? And having an alternate path from burning fossil fuels. Historically, commercial buildings on the cooling side have the option for electrification, right? We use chillers or compressorized units to do heating, to do cooling. It really comes down to the heating and getting a commercial tenant to be aware of like how heating is going to have to work, and changing, the facade or the amount of roof space we would need for an air cooled sort of approach to do that style of heat. And that's sort of why the facade becomes a major component to reduce the amount of load we need. And that sort of dovetails to your existing building portfolio, right? We don't want to just replace with what you have with a big, air source heat pump sort of solution for heating. We'd like to make the building's facade more energy efficient, get better controls to reduce the size of that equipment that you really need. Technology is slowly getting there. And different types of refrigerants, CO2 or R32, those are going to help us get there. But manufacturing and incentivizing manufacturers to come into the market is going to be a big thing to push.
Mixed use buildings really benefit from this type of system because of the off-cycle use of the building, where you can really capitalize on the times of day and when people are creating hot water or heat and when people want to reject that heat. We originally at Flatbush had a commercial component, and we had a water-cooled VRF system that was taking advantage of the times of day relative to that demand for hot water, and how we could use that to heat water for residents, for example, using the rejection heat from the cooling demand on the office side.
So Jared, you're obviously at 100 Flatbush is a new building. Have you taken a look at this from an existing building conversion standpoint? How feasible is it to do all building electrification on existing?
Yeah, I mean, I think there's different flavors of electrification for existing buildings, right? Historic buildings are a little bit more complicated, where the character or nature of the historic structure wants to be expressed or exposed. And so exposed building envelope walls are not the greatest up against heating demand.
They are pretty though.
they are beautiful. Obviously, we're focused on the carbon side of that equation, which is saving the building in the first instance, versus creating a significantly larger carbon footprint based on just the sheer energy it takes into making a building. So it is very valuable. And I do think there's going to be an entire industry around retrofit, where we are talking about building improvements, improvements to the building envelope, and the zoning and the code provide for FAR deductions, et cetera, for reinsulating or improving your building envelope performance without them counting or contributing to FAR or other things like that, where we will be able to do that more readily. But I think the real challenge is going to be in existing multi-buildings, when building codes that Greg referred to before, where appliance replacement, for example, might become a giant stumbling block, right? Where right now, everybody believed that residential residents had to have gas cooking, and that was the luxury feature. Now, when you're going to add an induction cooktop into that unit in the future, and you need an additional 50 amp, and your apartment panel for an 800 square foot unit is not going to be able to accommodate that, you're going to have to rerun, or update or upgrade an electrical system for the building to accommodate all of that additional demand. Happens to be intermittent, but our hope obviously is that the appliance manufacturers can create, products that have less of a draw than they do, and say something for induction. But, we believe people will be ripping out gas systems and ultimately having to upgrade electrical systems over time, which is another reason when we think about, building our first generational asset, where we have to plan for that future of more devices, more demand, being created for electrical than currently may exist today.
Yeah, and we're seeing that on the high-end condo market, where people are ripping out, the 6-burner stove and asking for the induction cooktop. So it's definitely, starting at the top and then going to, work its way.
Yeah, I live in a passive house and I couldn't even put in gas cooking because the amount of carbon monoxide that it would off-put would be dangerous for us because the building's so tight, right? So.
Right.
So one more question and then we'll do some Q&A, and there is a lot of it. So thank you all for everyone who's asked questions. I'm glad it's an interesting topic. Mr. Hale, what incentives are there out there right now, for building owners to go all electric?
Yeah, so there are a lot of things people can take advantage of. As a couple of our panelists mentioned today, there are existing incentives for heat pumps, both through NYSERDA and through the utilities. And those are available for both air source and ground source heat pumps. I believe the federal government also offers we reinstated the tax credit at least for ground source heat pumps in December. I'm not sure if they've gotten to the air source heat pump with the federal government yet. NYSERDA is also focusing on, and we will be evolving a new regime of incentives to go along with the coming mandates to try to incentivize early movers for building decarbonization. So that's sort of to come, but we also have a couple of programs that are in the market right now. One called Buildings of Excellence. It's actually focused on new construction, and it's a competition, but it has large prizes of $1 million, up to $1 million per project, and have had 48 winners through 2 rounds, and we have a 3rd round coming out in the fall. This is focused on multifamily, and it's about designing high performance all electric buildings. So pay attention to that one. We've got another project in the market called Empire Buildings Challenge that we just launched. This is with 10 major real estate companies in New York City, focused on existing buildings and sort of this technology gap that we've been talking about. What are systems that need to be imported from elsewhere? There's a lot of stuff that's operating already in Europe and Asia that we just don't have here yet. We talked about what's missing from the market earlier. Well, we're trying to focus on bringing that in through this. This is a prize system that will be up to $5 million per project. Each of these owners in this first iteration will be doing subsequent iterations of this. Each of the owners will put forth proposals for projects that they want to fund with this challenge money. And it'll be focused on these gaps in the electrification market and controls. We have Retrofit New York, which is looking at developing an entire new industry for taking existing buildings to net zero through without removing the tenants through exterior application of essentially prefabricated panelized envelope and then a new reduced because you've reduced the load through your envelope, new mechanical systems as well. That has an open rolling request for qualifications right now for manufacturers, but also for solution providers and building owners who are interested in trying to pilot early phases of this, and that will lead to significant incentives coming for demonstration pilots of that approach later this year or early next year, probably both actually.
So let's get to a few questions. There are a lot. One of them came in, and I will leave this to anyone who wants to answer it. Where do you see the future of steam? It too has a GHG impact, but building steam on the site is a huge lift if it's possible.
I don't see, and this is a personal opinion, but I don't see utilizing steam as an energy, as a building energy solution that is efficient enough for us, right? The steam is a legacy product that when back when we used to produce power at the city. Now there's a lot of buildings that rely on it and, rely on it for heating, rely on it for cooling. And, NYSERDA and Con Ed are going to have to balance how we produce steam and that carbon impact versus, retrofitting the buildings.
Yeah, it's a really difficult, thorny question. And you're dealing both with the large scale Con Ed steam system, which is, steam being produced at a massive scale and piped through the city and used in a lot of buildings, but you're also dealing with buildings that create steam through their own individual systems. So those are two separate questions. I think on the Con Ed one, the best I can say is it really requires study. And is there a way to decarbonize the production of that steam system through low carbon fuels like green hydrogen or enough renewable natural gas coming from food waste and animal waste? Is there enough supply of those clean fuels to keep the steam system? And is it less expensive to decarbonize the steam system than it is to rip the steam system out of the existing buildings? I think there are economic arguments that the steam system is so expensive anyway that it probably would collapse under its own weight. But this is I'm not an engineer, and it really requires study. But the good news is we know that it's a difficult question, and we're going to look into it.
And each building really needs to be studied on its own merit, right? Like Greg has pointed out, like facade replacements, even though we might not be able to get every building to fully decarbonize at a certain rate, but getting a better building to use less carbon is still, the goal, right? So, adding, exterior insulation, replacing windows, making sure the building leaks less, or just in general controls, right? Historically, steam fired buildings, turn on for 15 minutes and then turn off, and are based on a time clock. So anything to reduce is like the first step on a legacy building, and then full on replacement. Then we look at possible heat pump solutions, whether it be water cooled or air cooled. So it's a balance.
Yeah, we have a few existing steam buildings and have seen significant improvements on utility costs just by replacing the existing control system with the existing pressure-based control system with a smarter, modulating valve system. And it's been significant better performance already. Low-hanging fruit.
Low-hanging fruit, yep. Jumping to cogen, we'll probably get one more question and then just want some final thoughts, but what's the perception of cogeneration plants, specifically reciprocating engines, in the eyes of local law 97 or building electrification? And what are the building trends available in lieu of cogen?
Everyone jumping at
Don't
once.
Everybody, yeah, exactly. Don't everybody jump.
I mean, we're going to pay I think local law 97, sort of needs to evolve to how to deal with cogeneration. And I think it's a balance between what happens with NYSERDA and Con Ed and the utility. And as the grid gets cleaner, I would assume that there will decentivize cogeneration because of the carbon emissions. But like what Jared and Greg have said before is, like, right now the grid is dirty in New York City. So, cogeneration there's a benefit to cogeneration right now because, of the type of power we get in New York City. So
yeah, I think again, that's you got to split it into new systems and existing systems. Mm-hmm. From my policy world, without engineering background, I wouldn't put cogeneration in a new building if it's fossil fired, and I don't know any cogeneration that's not right now. Eventually, you could have fuel cells that are running on green hydrogen. That could work in the end. How to decommission, when to decommission existing cogen is really difficult. And I understand how frustrating it can be when 5 years ago, everybody was pushing, oh, do this cogen because it's gonna be the way to reduce your energy loads and work more efficiently. And now all of a sudden it's not the way we're supposed to be. It's just inconsistent with our climate goals, which have come much more into focus in the last 5 years.
So we have about 2 minutes, speed round. You each get 30 seconds, final thoughts on the topic, or I think you guys hit it on the head. How do you build up the demand, or advice to others on how to succeed, with full building electrification? Jared, I'll start with you.
Yeah, I mean, look, at Alloy, our mission is to create buildings that are beautiful, equitable, and sustainable, right? And we feel like we have an obligation to distort the use of the word value. And that value doesn't need to mean economics alone in the developed industry, although my peer set seems to think so often. So I feel that this is an opportunity to distort the use of that value. But in the end, things like the carbon cap and trade program that are going to come into focus are going to show people that there is actual economic value. And when buildings are stickier, because people don't turn over because they're renting because of this value set, is going to become critically important. So now's the time to start making the shift and to be thinking forward and to actually incentivize the big utility companies to create more infrastructure to accommodate us.
Great. Andrew?
Yeah, I think, by taking advantage of free balanced energy sources like ground heat exchangers and trying to tap into incentive programs, in addition to researching, new technologies. I think there are ways to achieve an electrified building with an acceptable premium of costs. In addition, though, I didn't mention it earlier, but I think it's extremely important that if developers, anybody is interested in electrification, that they study the use of real-time energy monitoring and smart controls, because having the ability to manage systems, whether it's either remotely accessible BMS or a shadow monitoring program or something of that nature, make sure that equipment runs at its highest efficiency ratings. There's just so much lost energy when things are running when they shouldn't be, and vice versa. Regardless of whatever systems put in place, performance and the ongoing monitoring is crucial in my mind. There's no set it and forget it mechanical system, and I think it's important to utilize those smart controls.
Greg M., you get 10 words or less.
10 words. Electrification can happen. We just need to change the school of thought that, the market has been in the last 20 years, and being open to new ideas, right? That's my 10 words.
Close enough. Greg Hale, final thoughts.
Mandates only work if they're practical. And the group here, all of the companies represented, including Turner, are at the cutting edge of showing that it is practical. And we've got to get this message out that we can do this and make it beneficial to the building owners. We also have at NYSERDA what we call the Carbon Neutral Buildings Roadmap, which is a project I've been leading, looking at how we actually get this transition done. And we're about to present our preliminary draft findings of that in June, next month, the 15th and the 16th. So if you want more than 30 seconds on how to do this, you can have 4 hours of it, but we'll have a lot of information in those sessions. So please tune in if you have a chance.
Excellent. Gentlemen, I cannot thank you enough for your time, your insight. Very much appreciated for you sharing the hour with us today. Again, thank you to Cosentini for helping us pull this together, and my counterpart here at Turner, Emily, for making this possible. Our next panel is June 17th, so after you tune into NYSERDA, you can come back to us for a commercial market outlook. And everybody stay safe, enjoy the warm weather, and we'll see you next month.
All right.
Thank you so much.
Everyone,
Thank you.
Thank you, Lisa.
Bye.